In this video, we're going to talk about another threat to secure networks, which is denial of service attacks. So what is it? A denial of service attack is first you have your server that's up and running, and then it's flooded with a bunch of attack packets that essentially close it, making it inoperable or unable to access any site or any piece of that particular network. So what it is not is faulty coding. So if you do some mathematical or algorithmic mistake on your own system that causes your system to no longer function, this is not a denial of service attack. This is just faulty coding. Additionally, it is not too many referrals. So take, for example, there are many sites out there that publish, we have the sale going on, and a bunch of users try to take advantage of the sale only to find out that the site is overwhelmed, that it can no longer function. For example, Red Robin offered a deal of French fries and hamburgers for an entire year for a nominal amount. And when they started this promotion, when users went to try to take advantage of it, the site locked them out and they were unable to actually take advantage of the deal until a bunch of users left, and those that stuck around were able to take advantage of the deal. So the goal of denial of service attack is to cause harm, either in the fact of stopping the network altogether or slowing it down. This harm could lead to the loss of related sales, industry reputation, employee productivity, or even customer loyalty. It might even be done by competing organizations or other governments to be able to boost their own reputation. So there are various methods of denial of service attacks. The first one is the direct attack, where the attacker tries to flood a victim with a stream of packets directly from the attacker's computer. This is rare because in order to be able to take down a device, you need to be able to have more processing power and higher bandwidth to be able to take down this other computer. The next type of attack is the indirect attack, where the attacker spoofs their IP address or fakes it, where the attack appears to be coming from another computer. And when that computer that received these packets tries to respond, they send all those packets to the computer with a legitimate IP address. And if it's enough packets, it can take down not only the computer that's being attacked, but the computer that is receiving the indirect attack as well. The next type of attack is the intermediary attack, where the attacker activates many bots to flood a victim. So in this case, they could compromise a bunch of computers, or they could go to the dark net and hire out a bunch of these compromised computers for pennies to hundreds of dollars, depending on what the service requires. And then they have access to hundreds of thousands of computers that they can then send an attack command to a specific server, for instance, and take it down. The next type of attack is the reflected attack, where an attacker uses responses from legitimate services to flood a victim. These could be like peer-to-peer services, etc., where they just send a bunch of information to them, and all these peer-to-peer services reply to the victim instead of to the original and essentially take it down. And the last denial of service attack is sending malformed packets, where the attacker uses malformed packets to cause the victim to crash, like a ping of death or SMS of death. So these denial of service attacks against these servers are getting very sophisticated, where multiple terabits of data are sent to servers. So these servers have to withstand huge amounts of data coming into their network at one time in order to ensure that they stay up and running. So there's various types of packets that can be sent to take down a device. So we have FTP, HTTP, ICMP, IRC, SMTP, SYN packets, SYN acknowledged packets, TCP, UDP. So we've talked about most of these packets, and all of these can be used if they're sent over and over and over again to be able to essentially bring down a victim. So one example of this is the ping flood attack, also known as ICMP. And the ping issues a request to a specific server, for example, orman.creighton.edu. And this victim is going to either respond or not respond, depending on whether or not ICMP is enabled or that it is actively available. Then in this command, the attacker can send packets until terminated using the T. Otherwise, on a Windows machine, it would only run 4 pings and then stop. On Linux, it runs until you actually tell it to stop anyway. And then if you add the L flag, you get to specify the load sent in bytes. So that would be 65,000 bytes per ping are sent. One machine is not enough to bring down the host. However, if you're able to take a bunch of machines in a botnet, for example, and send the same ping attack to one device over and over and over again, you could potentially bring it down, or at least slow people's ability to access the server. So now I want you to try this learning activity to see if you can detect the source of a denial of service attack. So we're going to use this site. I want you to follow the instructions on this, so pause this video, try this on your own, and then come back for discussion. All right, welcome back. So let's go ahead and enter the IP address that we saw on the slide, and then you can select any location that you want. Let's go ahead and do Germany, and then click Trace Route. This might take a minute to load. And here is the map with the directions. So it gives a map of how far my package traveled in order to get to where I currently am. So you notice that there's different hops. So we talked about the hop limits, but essentially it's gone through 14 devices. Some of these have been masqueraded so that we don't actually see those. So where did the first IP address seem to be located? Well, the first visible one that we have was located in Germany. And did the route go anywhere unexpected? Not really. It went straight across all the way to here at Creighton University. So how could this website benefit us in a denial of service attack? Well, if we see attack coming from a specific country, we can find the IP address and potentially prosecute the individuals that are engaging in this denial of service attack. So let's do another one, and let's pick a different location this time. And you can see all the different bounces it had to take to get from Hong Kong. So this one took at least 19 routes. Some of them are hidden again, and it went from Hong Kong to Singapore to London to Mountain View, California to New York City, and then ended up where we're at. So if you didn't try the other ones on your own, feel free to continue to try those, but this should give you a gist of what this is about. Thanks for watching my video. Feel free to click the links here to watch the next video of the playlist, continue to the next playlist, or subscribe.